Let's go to guided practice 3. Find the horizontal asymptote of the following rational functions. This time, we got to use the limit. This is the facts for limit. Think about this way. For that x, let me do 1 over 10. You will get 0.1. 1 over 100. That will be 0.01. 1 over 1000. You will get 0.001. Now let's do 1 over 10,000. You will get 0.0001. So we keep going. When we get infinity, really big number, then you will get 0.000, keep going. Even we get a negative number, for example, here. When we have 1 over negative 10, you will get negative 0.1. 1 over negative 100, you will get negative 0.01. 1 over negative 1000, you will get negative 0.001. So you keep going. If you go to negative infinity, you will get the negative 0.000, keep going. That's the reason we will say when limit x tends to positive or negative infinity, 1 over x both go to 0. Let's recall what we learned before. If we have a rational function r equals p of x over q of x, then the vertical asymptote line, you will get the q of x equals to 0. Make sure your denominator equal to 0 so that you can get the vertical asymptote line. For the horizontal asymptote line, we got to use the limit to get that. So you will get the y equals limit as x tends to infinity of r of x. Since we already learned limit, so this time we got to use limit to figure out the horizontal asymptote line. The vertical asymptote line make a denominator 2x plus 5 equal to 0. You will get the x equals negative over 2. For the horizontal asymptote line, we will use a limit that will be y equals limit as x tends to infinity of 11x minus 8 over 2x plus 5. You will find the x with the highest exponents, that is x. So divided by x, every single term for this rational function, we divide it by x. Then we reduce. You will get limit as x tends to infinity of 11 minus 8 over x, 2 minus 5 over x. When x tends to infinity, any number divided by x, this will be 0. This will be 0. Therefore, your final answer will be 11 over 2. So y equals 11 over 2 will be the horizontal asymptote, and a vertical asymptote line will be -5/2. This is the graph for 11x minus 8 over 2x plus 5. Y equals 11/2 is the horizontal asymptote line. For the vertical asymptote line will be x equals -5/2. Now let's go to number 2. The vertical asymptote line, we will make a denominator equal to 0. So you get add 7 both sides, 2x squared equals 7. Then divided by 2. So you get the x squared equals 7/2. X equals plus or minus square root 7/2. This will be the vertical asymptote line. For the horizontal asymptote line, we will do y equals limit as x tends to infinity of 10x minus 2 over 2x squared minus 7. The highest exponent is 2, so everything we divided by x squared. For this rational function, you will get limit as x tends to infinity of reduce for x over x squared, you will get the 10 over x minus 2 over x squared. Then you get the 2 minus 7 over x squared. To simplify, whenever you see the x as denominator will go to 0. So this one go to 0. Here's a 0. 0 minus 0 is a 0. So when numerator is a 0, then you will get 0 because 0 divided by any number will be 0. Now here's the graph. You could see the horizontal asymptote line will be y equals 0. That is x-axis. When x tends to positive or negative infinity, the graph is getting closer and closer to x-axis. Yeah, let's go to number 3. You could see the vertical asymptote line, that is 7x minus 5 equal to 0. X equals 5/7. For horizontal asymptote line, we got to use y equals limit as x tends to infinity of 3 minus 4x squared over 7x minus 5. The highest exponent is x squared, so we divide it by x squared for every single term. Then you can simplify. This is 1, so here is x. You will get a limit as x approaches infinity. Get a 3 over x squared minus 4. 7 over x minus 5 over x squared. Whenever you see this x, its a denominator will go to 0. So you will get -4/0. When 0 is a denominator, then you will get undefined. In other words, no horizontal asymptote line for number 3. This is how the graph look like. You could see we have oblique asymptote line. We don't have a horizontal and vertical asymptote line for these rational functions. Let's go to number 4. we will figure out the vertical asymptote line. Make a denominator equal to 0. So you will get the x third power equals 7 over 8. X equals cubic root of 7 over 8. Cubic root of 7 over 2. That's the vertical asymptote line. The horizontal asymptote line, you will use y equals limit as x tends to infinity of 9 minus 2x third power, 8x third power minus 7. The highest exponents, that is 3x third power, so we divided by x third power for every single term. Then reduce. You will get a limit as x tends to infinity, 9 divided by x third power minus 2, 8 minus 7 over x third power. Whenever see the denominator is x after you simplify, then it goes to 0. Therefore, you will get a negative 2 over 8, that is a negative 1 over 4. This is the graph. Here is y equals negative 1 over 4. You could see when x tends to negative infinity, this graph, and it will keep going very, very close to this y equals negative 1 over 4, this horizontal line.